Right. Uh, thing I want to talk about, and that is the topic of orbital hybridization. Okay, orbital hybridization. Now, before we start this little topic, we will go ahead and draw some simple Lewis dot structures first. And there are some Lewis dot structures that I would say, everybody should know how to draw them. So let's start with CO2. How about that? Let's start from CO2. Oh, actually, let me go ahead and step back a little bit here. Let's start with, let's see, what's a good one? Let's start with H2. How about this? H2 first. Okay, H2. And then let's go ahead and draw CH4. All right, CH4. Let's go ahead and draw something like BF3. How about that? And then we draw CO2. Okay, so let's go ahead and draw these four diagrams. Okay, you can pause the video and draw them. Okay, now, so these four diagrams, go ahead and draw some squares to separate them so that we can see them a little bit easier. Now, we're going to develop today's topic with these four structures, okay? So they're pretty easy to draw, and if you draw them enough, you probably don't need to rely on all those methods anymore. You should be able to draw these structures, okay, really by heart. But if you have to rely on the methods, sure. So these structures, they're pretty straightforward, they all achieve octets. This one, BF3, it's a little bit special because boron has only, needs only 6 electrons rather than 8 electrons. And CO2 would have a pair of double bonds with oxygen, okay? Now, we also talked about the need of counting the number of electron densities, right? So let me go ahead and use a highlighter to highlight electron densities around the central atom. So for H2, let's just say the one hydrogen atom on the left is the central atom. It doesn't really matter. So there's only one electron density, which is fine, okay? And then for CH4, there are 4 electron densities right here. And then for BF3, there are 3 electron densities. And when you have CO2, you have 2 electron densities. I think we have a good variety of electron densities right here. Now, and let's go ahead and also talk about those geometries. Okay, let's start out with electronic geometry. Geometry, which is the first thing that we need to look at. And then we will talk about the molecular geometry. Okay, and I'm a bit lazy. So let me go ahead and copy and paste these questions so that I don't have to write them again and again. Okay, so by now, hope you can do this mentally. So for H2, they are both linear because, well, it's just a line. So what else? For the methane, CH4, it will be both tetrahedral. Now, if you look at all four structures, there's no lone pair electrons at the center. So the electronic and molecular geometries would all be the same. We have trigonoplanar for BF3. And then we have linear for both CO2. Okay. And coincidentally, all 4 of these structures are nonpolar molecules, despite having either nonpolar or polar bonds, because all the dipole moments or the arrows that you draw, they would get canceled out perfectly. Now, so when we have all these written down, then let's go ahead and talk about the biggest topic of today. So for this video, I'm going to separate this into 2 parts. Now is the first part. I will teach you how to tell orbital hybridization, okay? Just simply getting the answers right, okay? If you know how to count the number of electron densities around the central atom, then you know how to get the hybridization correctly. The second part of this video, or the next video, we will be talking about the reason why we need something called orbital hybridization, or what led to the discovery of the orbital hybridization. Okay, so first, let's get the answers right first. Okay, so if there are two electron densities, okay, how about this? I want to save some writing here. So let's just say number of electron densities, okay? Then we have orbital hybridization. Okay, if you have two electron densities, it's known as SP. If you have three electron densities around central atom, then we shall call it SP2. If we have four electron densities, then we shall call it SP3. And if so 2, 3, 4, right? Now we could have 5 and 6 electron densities, and for these situations, and let me go ahead and put an asterisk next to it. These situations happen when we exceed octet. Okay, when we do exceed octet, that's gonna it's gonna happen. Now, then what will be the hybridization? I'm gonna hold on this. I'm gonna leave these two blank. Okay, for now, and we'll come back to this. Okay, if you say, is it SP4? I would say no, it's not SP4. Okay, but we'll get to that in a moment. Okay, so if we go back, okay, so we say, what about methane? Methane is there are 4 electron densities. So at carbon, the orbital hybridization is known as SP3. Okay. For BF3, what's the orbital hybridization for boron? And that would be SP2. And for the carbon right here, what about the carbon right here? What's the orbital hybridization? Well, there are two electron densities. So therefore, we have an SP hybridization. Okay. So in terms of how to get the right answer, that's how to get it. Now, you must be thinking, wait, hold on. Is there an easier way to get these, like to pair them up? Let me offer you a suggestion. So if you think about these as exponents, okay, if you don't see the explicit exponent, so that means the implicit exponent is 1, 1 plus 1 is 2. Okay, so for the S, it's always a 1. So 1 plus 2, 3, 1 plus 3, 4. So there's really no way to get things wrong if you know how to count a number of electron densities. All right, and let me just go ahead and give you one more quick example. Okay, let's just say we have NH3, ammonia. All right, ammonia. How many electron densities around around the nitrogen? 4. So therefore, this nitrogen would be sp3. Okay. All right. So that's how we get to the right answer of counting the labeling these central atoms or any atoms. Okay, with the correct orbital hybridization. You simply need to count the number of electron densities, and you shall be able to get it right. Now, I haven't told you about the hybridization for 5 electron densities and 6 electron densities. So let's go to the next video and let me explain a little bit more, and then you'll be able to figure these two out. Okay.